Okay everyone, let's go ahead and take a look at section 21C, which is called the derivative function. Now let's go ahead and make some extra progress from where we were in the last section. And remember that we said that, say for example, if we let f of x be equal to x squared and x be equal to 2, how can we find the instantaneous rate of change of the function at the value x is equal to 2? In other words, how do we find f prime of 2? Now, there are a couple of ways that we could do that. One, we said that we could actually use f prime of a is equal to the limit as x approaches a of f of x minus f of a divided by x minus a. The other way that we did it, the other way that was introduced in the last section, was f prime of a is equal to the limit as h approaches 0 of f of a plus h minus f of a divided by h. Now, let's kind of review this one here because we're gonna focus on this one. Now, if we went ahead and took f prime of 2, because that's what we're trying to find here, that means then that all the values of a need to be changed to 2. And then after that, it's more or less following your rules for evaluating functions for these values here and evaluating the limit. So we took 2 plus h, quantity squared, minus 2 squared divided by h. Again, notice that if we wanted to substitute the value of 0 in for h at this point, we would come up with 0 over 0, which doesn't make any sense. So I would expand this and come up with 4 plus 4h plus h squared minus 4 divided by h. Notice that the 4's will cancel and I come up with 4h plus h squared divided by h. Again, if I still substituted the 0 in for h at this point, I would still come up with 0 over 0, which does not make any sense. So I need to continue to simplify until finally, at this stage here, if I substitute the value of h, 0 in for h, I come up with the value of 4, and this is consistent with what we had before. That's 4. Now, let's say, for example, that I wanted to go ahead and calculate the derivative at 3, at x is equal to 3. Oh my goodness. That means then that what I need to do is I need to do this, which means that I have to go through this whole process again just to determine what the value of the derivative is at x is equal to 3. What about if x is equal to 4? What about 5? What about 3.2? Does that mean that you actually have to go about going through this whole process, which is starting from basic principles, to determine what the derivative is at a particular value of x? Now, the nice thing about mathematics is that, of course, is no. You don't have to go through that process. So what do we need to do then? What we need to do is we say, okay, let's go ahead then and say that we want to go ahead and find the derivative function called f of x. F prime of x. If we can find this, then once we go ahead and determine a value of x that we want, we just substitute it into the function and evaluate the function as if we would normally evaluate a regular function. So how do we go about doing that? Well, we're not going to use this one here. Again, what I said is that we're going to focus on this one here. Now, if I was to go ahead, instead of trying to find the instantaneous rate of change at a particular value of a, why don't I go ahead and say that I want to do it for any particular value of x? If that's the case, then I need to go ahead and change this from an a to an x. And I need to also go ahead and change this from an a to an x. And this is the definition of the derivative, the derivative function. So, in order to find f prime of x, or the derivative function of f of x, all I need to do is take the limit as h approaches 0 of f of x plus h minus f of x divided by h. Okay, so let's go ahead and do this for this particular function here. Now, of course, the question is slightly different. It says let f of x be equal to x squared. What is f prime of x? What is the derivative function for this? Okay, let's go ahead and start. we do exactly the same thing that we did before, except for what we're going to do is we're going to substitute the value of x plus h into this here. So what we have then is we have the limit as h approaches 0. This is going to be x plus h quantity squared minus, this is going to be x squared. Oops, sorry, it's x squared. And this is going to be divided by h. Okay, so what happens then after that is we just go ahead and just do the same thing, the limit as h approaches 0. If we were to go ahead and expand this, we do exactly the same thing with the expansion that we did here. This is using the FOIL method, so we have x squared plus 2hx plus h squared. Okay, that's what that is. And then of course minus x squared. And then divided by h. Okay, so notice that what happens then is we want to go ahead and simplify, very similar to what we did here, but except for we don't have necessarily any numbers per se. We have a lot of x's and h's, but still we do the same process. The limit as h approaches 0, the x squareds cancel, and we have 2hx plus h squared divided by h. Okay, now remember that even in this case over here, when I tried to substitute the value of 0 in for h, it doesn't make any sense because you have 0 over 0. In the same respect, if I put that value of 0 in for h here, notice that it says 0 plus 0 divided by 0. There's still 0 over 0, which doesn't make sense. So what we need to do then is we need to factor out the h. The limit as h approaches 0. This is going to be h times it by 2x plus h, and then that's all going to be divided by h. So then if I cancel out the h's, I come out with the limit as h approaches, as h approaches 0 of 2x plus h. Now if I go ahead and substitute the value of 0 in for h, I just come up with 2x. Oh, okay. So what that means then is that this f prime of x, or the derivative function of f of x is equal to x squared, is actually equal to 2x. So what does that mean now? What that means is that regardless of the value of x that I choose, I can now go ahead and calculate the derivative at any particular value of x using this very simple formula. So notice that with our previous result, or our previous question I should say, we wanted to find out what f prime of 2 is. Well, that's just a matter of just substituting in the value of 2 in for x for the derivative function. And sure enough, this is going to be 2 times 2, which is going to be 4, which is exactly consistent with what we had before. Now, of course, the part of this now is that what if I wanted to find f prime of 3? F prime of 3 is just 2 times by 3, which is equal to 6. The instantaneous rate of change for this particular function at x is equal to 3 is 6. So, what you can do now is you can calculate the instantaneous rate of change for any function for any value of x for which the function is actually well defined. So, if we go ahead and use this here, which is based upon all of the basic principles that we've shown, we can actually come up with a function that is called the derivative function, which we can then go ahead and determine the instantaneous rate of change for any particular value of x on the function. Okay, so there you go, section 21c, the derivative function f prime of x. Okay, go get them. See you next time.